Yes. So my name is Chunyoung Park. I'm an aerospace engineer at Pyramid Space. I've been working at Pyramid Space for 10 years, and I like to just share the about the space economy. And you guys might be questioning why presenting a space economy, not the propulsion system or aerospace system, because I kind of realized the importance of the space economy, and it actually affects to the engineering development. So I'm really interested in this area. So I personally kind of study and research this area, and I'd like to share the overview of space economy and how and why the advanced propulsion system is important for the future space economy. So like to just go over this. Just old and what's old and new in space economy. And there's actually no economy in the past, and only the government was leading the development and the use of the technology. So like we just define it as a old space economy, like government leads, and of course, the government spent, as much money they could to develop all the system, and they use those data for, sometimes military and their, in the needs or research. However, as time goes by, there's so many, like other, engineering, technologies developed, and then we are able to kind of develop the space technology a cheaper way. So now this small company or the private company start developing space application systems, so that new space economy just comes out, and it was pretty much successful. Like it was way cheaper than the government led development, or and then it also produced some sort of profit over the across the technologies. So now it's accelerating the technology developments, and it helps a lot of uh, the country's powers. And some researchers are not really interested in like space economy. They don't like to hear this economy, because most researchers or scientists spend their time without considering economy. But I would like to say the economy is a really help for them as well, because it allows them to do more research actually. So I think we really need to consider, and everybody needs to get help to do the new space economies. So there are several, some charts for this is a summary of the benefits of the new space economy. Like I just categorize the stakeholders as government, enterprise, and scientists and public. They all get benefits from the new space economy. And I like to especially, talking about the scientists, like they get more research opportunity over the space economy, and also the public. So they will eventually, all public will get benefits like space tourism and things like that. So I'd like to share this chart. I'm not going to talk about the detail of the rockets today. However, I just want to compare the two examples to emphasize why the new space economy really matter, and it's really helping our economy as well. So the SLS in a Block 1, which NASA is currently developing and pursuing, they're like in the Starships, which is SpaceX developed, and the size wise they're pretty similar, and which is about 120 meters long and about the same diameter, but their capabilities are really different. Like the SLS can only lift up like if 43 tons to TLI, while Starship can launch like 150 tons to TLI, which is about 4 times or 3 times more than SLS Block One, and the cost is dramatically different. Like SLS Block One, the general cost for the launch is $4 billion. However, Starship is targeting like $1.5 million per launch, so it's not even computable. It's more like 1,000 times cheaper than NASA rockets. So you can do more. You can launch more payload, and you can reduce the cost a lot. So the scientists and all other industry can uh, launch their payload and get benefits from it. So I like to share this chart to just analyze how this, space economy like allocated. Uh, as you can see, the total global space economy is like about $600 billion in 2024, and I want to just keep every other things, but the launch service, however, it takes $22 billion from the total space economy, which is about 4%. What does that mean is the launch is the economic, value wise, the launch service is not much has impact for the global space economy. However, unlike other economy, the launch is the first step of this space economy. So I would like to say, although there are not much a market up there, but it's really important. So that's why um, we have to kind of concentrate on this market. And of course, this is my personal opinion. This, because of the limits of the launch service, we are having this allocations. So this is a slide showing uh, the evaluation of this of the market share. As you can see, almost 50% of the market is the satellite, and all the profit and market shares coming from the satellites, and so 30% about the cargo, and 50% is the human space flight, which is almost the uh, dedicated to the ISS mission. However, almost 70 to 80% is coming from the cargo mission and satellites. And this means that the launch capabilities are pretty limited. Even today, we can only launch satellites in lower Earth's orbit or the moon, or even the SpaceX targeting Mars. And it's a really challenging mission. So they are just trying to concentrate on the satellites and all this. So now the current market is kind of set to satellite launch or cargo transport and space station mission or cruise transport. And will not be much different from the future unless you're developing new types of launch system. And then the future market we are hoping to happen is the space tourism or the point-to-point space flights or the cargo transport, but at different location like OTB or robotic mission in space and microgravity wrap or things like that. These are the new market we can dreaming of, but without the new space launch system, it's really difficult to achieve. But we're really targeting this, and a lot of governments and the industry are looking for this type of technologies. So I'd like to just share just quick um, overview why we cannot really develop the new types of rocket or the engine, because the chemical propulsion is the only considerable propulsion system for the rocket for the launch vehicle. And the NASA actually tested all possible chemicals to improve their launch system and rocket engine performance. And as a result, we are able to conclude that the specific impulse will be limited somewhere in between 300 to 450 seconds, which is not much different from what we have here. So we have to kind of sacrifice all the fuel to launch a rocket, and we cannot really escape from this phenomenon by physics, not by physics. So so like the SpaceX, to reduce the cost, they developed the new types of launch system, like a vertical landing system or the capturing system to save their their boosters, so that they can save the money and they can just recycle them to launch faster for the next mission. And there are some other approaches, like there are several ways to save money for launch wise, because sometimes there's a limitation for the launch sites. So the China or any like other company looking for like a sea launch system to provide more frequent launch opportunities, so that they save more time and money too. And some other U.S. companies trying to use the airplane or the horizontal landing system to save their cost or expand their launch capabilities. And sometimes the horizontal landings provides the crew returns and low impact for payload when it's returned. So these are the marketable approach. So the NASA, this chart is providing just the plan for the future space transportation. So because we have to make a economical approach for the space utilization, NASA developed kind of separate and segmentize the area of the space technology. Like instead of just going directly to the moon by one single giant rocket, they try to use a range of rockets and just only deliver packages to the nearest orbits. And nearest orbit, it deliver that package to station by using OTV, orbital transfer vehicle. And there's a lander that takes the payload to the moon or Mars and comes back. And they recycle OTVs and all the launch systems, so that they save time and allows more economical space utilization. So now, this is the fun part of this slide. We kind of understand the importance of the propulsion system. And we also know its chemical propulsion is really limited, and how we're going to overcome this. If we are able to overcome this, we can deliver more weights of the payload, and we can totally try a different launch system as well. And what's the definition of the advanced propulsion system? This is my definition, which is the specific impulse should be bigger than 400 seconds, and at the same time, it needs to have a high thrust. We have to achieve this both of targeting goals. Otherwise, you will not be able to launch from the Earth. And why 400? Some people ask me why this specific impulse is bigger than 400, because any beyond 400 seconds space impulse allows to do single stage orbit launch capability. What that means, we don't need the separation of the rockets. So there are several candidates we be able to do, which is a rotating detonation engine. NASA and other countries have developed country researching on this type of rocket engine. And the fuel use LOX and methane, and sometimes use LOX hydrogen. And with this fuel, with this technology, and you can achieve like full space impulse between 400 seconds and 500 seconds. And what's the rotating detonation engine? It's kind of making a detonation while it's combusting fuel, and using the detonation waves to improve this the rocket performance. So JAXA, Japan Aerospace Exploration Agency, was actually developed and utilized this engine. And this is about the size of the engine, and it is used for the mid and large size of the satellites. And also NASA develops the same type of engine, and they're still under research right now. And a startup company which is called the Venus Aerospace, also developed this engine and trying to apply their technologies for point-to-point space plane. So here are some advantages and technical challenges for the RDE. Of course, it has really high space impulse, better combustion efficiency, and reduced engine mass. However, the ignition part is really difficult. You have to create a detonation, and the timing is really matter. You have to, like, 1,000 times per second, you have to make a detonation, which is really challenging. And ignition is also challenging. So it's really difficult technologies, and maintain durability, because every time you make a detonation, it really damages the engine. And of course, also it's really make it large. It's really practical for certain sites. So these are the technical challenges. And there's another approach, which is a nuclear thermal propulsion. In the past, the nuclear is really highly sensitive, technologies. But nowadays, there's other nuclear types of nuclears, not like uranium or plutonium. There's other types of nuclear like thorium, which is much safer than uranium, and the thorium could be melted into the molten salt. So whenever it's destroyed, it will be hardened. So it's not gonna be it's no longer be active. So there are several technologies that are developing right now, and use the thermal energy. It can be used for the space propulsion system. But still, due to the hazard of the nuclear, they're trying to use for the space exploration only. And the performance-wise, it uses hydrogen, and the specific impulse is about targeting about 900 seconds, which is almost triple and double and triple times, more efficient than chemical rocket engine. And I would like to introduce my research. I research is electric and chemical thruster, which is kind of hybrid types of a propulsion system. Use the electric energy and chemical energy to enhance the overall propulsion capability. So you can get any electric power from the sun, and using those extra energy, you can actually enhance the performance of the chemical thruster. So by this design, you can increase the space impulse by 700, and which is quite improvement. And there's another approach with, instead of just using a chemical propulsion, sometimes there's other application like a space plane. Space plane needs a certain deep throttle ability, and sometimes planes need to use a runway, airport runway to take off, and you need to, the engine shouldn't be idle at all times. So this rocket engine allows to do those type of operation, and unlike the conventional rocket engine, this conventional rocket engine, you just start the engine, you'll get almost a full throttle. So this engine will allow to do more smooth operation. So thank you very much.